In this video, we're going to find the area of non-standard shapes. So there are no formulas for finding the area of more complicated shapes. However, we can use the strategies that were introduced in the beginning of this lesson to help us find these areas. Find the area, break up the areas into shapes that we recognize, and add the area values together. So we learned a bunch of strategies for finding areas, the adding method, subtracting method. Here they suggest we use the adding method, so that's what we're going to do. So looking at this figure, so there's no formula for this figure. We could make one, but if we made a formula for every weird shape there was, we'd literally have infinitely many formulas. So instead, we're just going to cut this into shapes we recognize. And I look at this and I see a rectangle with a triangle tacked on to the bottom of it. So I'm going to cut this right here. And I'm going to find the area of this rectangle and this triangle and add the results together. So first, I think the area of the rectangle will be easy. Okay. We want to multiply the length and the width. We have the length and the width. 18 centimeters times 6 centimeters. 18 times 6 is 60 plus 48, which is 108 centimeters squared. Feel free to check that on your calculator. And now we want to find the area of the triangle, which looks like it's going to be more tricky. Okay, so let's kind of draw a separate diagram for the triangle so we can look at it in isolation. Okay. And there's all sorts of numbers floating around here. So we know that to find the area of a triangle, we need a base and the height that corresponds to that base. Okay. Now notice the numbers we're given. We could think of 9.5 as the base, but notice we don't have the perpendicular distance to, that vertex. Okay. If we think of this as the base, we'd need this distance right here, which we don't have. If we think of this as the base, notice they give us this 9 centimeters, which is the perpendicular distance. Okay, so this is the one we're going to want to use. We don't know this base, but at least we know we have the height. So this height is going to be 9 centimeters. And now we just need to find the length of this base. Okay, so notice, I'm going to draw this in blue. Okay. We don't know this piece, but we do have other information. We know that this is 18, and this is a rectangle, so this is 18, and we know these two other pieces. So let's draw a little double number line. So we have 18 centimeters is this whole length. Down here, we have that same length, but it's cut into 1, 2, 3 pieces. One of the pieces is 6 centimeters. This little piece to the right is 3 centimeters. And the piece we're looking for is the middle piece, which we don't know. Now, since these two pieces are equal, okay, in order to make this to sum up to 18, this is 6, this is 3, that's 9. The middle piece must also be 9 centimeters. So now we have the base of this triangle, 9 centimeters, its corresponding height of 9 centimeters, and we can find the area. So we have 1/2 the base times the height. Okay. There's no even numbers, so there's going to be a decimal, so it's going to be 1/2 of 81. Let's just start from the beginning. So for 1/2, we'll do 1 divided by 2 times 9 again. Gives us 40.5 square centimeters. So our total area is the sum of these two pieces. So 108 centimeters squared plus 40.5 centimeters squared gives us a total of 148.5 centimeters squared. Let's look at the next one. Find the area of the given shape. Compute using 3.14 for pi and round to the nearest hundredth. Okay, so when I look at this shape, I see part of a circle that kind of looks like a Pac-Man, and part of the circle is cut out and replaced with a square. And I know it's a square because this says 2 feet, this says 2 feet, so this must be a square. Notice I have the 90-degree angle marked here, so that tells me that it's a square and not a parallelogram. Okay, so I'm thinking I want to find the area of this Pac-Man part and the area of the square, and I'm going to combine them together. And since this isn't a full circle, I need to determine what fraction or part of a circle this is. So notice I'm going to just cut this into pieces. I'm going to draw a line straight across for a diameter and straight up. And because this is 90 degrees, this is 90 degrees. So all three of these pieces are equivalent. If this was a circle, then this would be the fourth piece. Okay, so we have 3 out of 4, or 3/4 of a circle. That's our first piece that we want to find. And the second piece is a square. So let's find these areas. So first, I just want to get rid of this red part. This was the first piece we want to find. Okay. So we're going to use the formula for the area of a circle, but we just want 3/4 of what the entire area would be, because that's the fraction we have. So 3/4. Okay. Pi, they told us to use 3.14, so I'm going to put that in there right now. 3/4 times pi times the radius squared. And notice the radius of the circle is 2 feet. So 2 squared. Let's compute this on the calculator. Okay. 3 divided by 4 times 3.14 times 2 squared, which is 4. And we get 9.42 feet squared. Now we'll find the area of this square portion. Okay. So just like a rectangle, the area of a square is length times width. The length and the width just happen to be equal for a square. So we want to multiply 2 feet by 2 feet, and that will give us 4 square feet. And now to find our final area, we sum up these pieces. So we have 9.42 feet squared plus 4 feet squared. Adding these up, 9 and 4 is 13.42 feet squared.